Hello, this is Charles Margosian from New York City, presenting joint work with Lawrence Soule on variation inference for the upcoming Uncertainty in Artificial Intelligence conference. And our work focuses on variational inference, where we try to approximate a target distribution, for example, a posterior distribution in the Bayesian analysis, using a family of tractable distributions. And the way we do this is by minimizing a Kolber-Kleibler divergence. And one common assumption is that the approximation is factorized, meaning the components are independent. And this is done out of computational convenience. In practice, the target is not factorized, so we introduce an error. And we want to understand a little bit, how does this error in our approximation manifests? And what previous studies have shown is that the factorized approximation tends to underestimate uncertainty. Okay, so what exactly does it mean to underestimate uncertainty? So to formalize this notion, we decided to first look at a simple example where we have a normal target and a factorized Gaussian approximation. And the reason to look at such a simple example is that, one, you can actually do your theoretical analysis in a rather elegant way, but two, this still gives you counterintuitive results, which then we apply to more realistic settings with non-Gaussian targets. And the first thing we're able to establish is we have a general proof that, yes, you do underestimate the uncertainty. We look at two ways to measure this. One is the variance, the other one is the entropy. But then we wanted to ask, well, how do the two relate, right? Since entropy can be thought of as a generalization of variance. And what we were able to show is that the entropy gap is going to be the result of two competing forces. One is due to the variance shrinkage, but the other one is due to the decorrelation or delinkage of the graphical model. And in fact, the delinkage can almost entirely compensate the variance shrinkage, which means that you can have scenarios where you have arbitrarily poor estimates of the variance, but very accurate estimates of the entropy.